Ever wondered why your streaming service always seems to know what you'll love next? Or how your phone's weather app predicts rain before you step outside? It's not magic, it's math, and today we're unraveling a breakthrough that's changing how machines make smart decisions. Let's dive in. Imagine you're running a coffee shop with 10 different brews. Every day, you have to choose which one to feature on your menu. You want to pick the one that'll make customers happy, but you don't know which one is best, yet. So you test a few, learn what works, and gradually narrow down your choices. This is the classic exploration versus exploitation dilemma, trying new things to learn, then sticking with what's proven. But what happens when there are thousands of options, not just 10? That's where contextual bandits come in. A contextual bandit is like a super smart barista that learns from every customer interaction. It uses clues, like a user's browsing history or the time of day, to pick the best option. But here's the twist, real-world data is messy. Think of it like trying to predict someone's mood based on 1,000 factors: temperature, social media activity, even the weather. Traditional methods assume simple, straight-line relationships, but life isn't that neat. That's where kernelized contextual bandits step in. These models use something called a kernel function. Think of it as a superpower for measuring how similar two data points are. Instead of forcing a straight-line guess, they can spot complex nonlinear patterns. But there's a problem. When there are too many features like those 1,000 mood factors, old methods start to fail. Their performance plummets, like a car driving into a traffic jam. The regret, the gap between their choices and the best possible ones, grows linearly with data, which is bad news. So how do you fix that? The researchers behind this study made a clever move. They assumed the data had a hidden structure, like a secret recipe. By doing so, they showed that even with huge amounts of data, you can still make near-perfect decisions over time. They introduced a concept called lenient regret, which allows for tiny, controlled errors, like giving yourself a little leeway when baking a cake. It's not about perfection, it's about practicality. The real game changer. A technique called kernel interpolation. Imagine you're drawing a smooth curve through scattered dots. Even if there are millions of dots, this method adapts, thanks to an invisible regularization effect that keeps things from getting too complicated. It's like having a magic eraser that removes the noise without wiping out the signal. And the results? In tests, this approach outperformed older methods by a landslide. For example, when predicting user preferences in a recommendation system, it reduced long-term regret by up to 40% compared to traditional models. The key insight? By leveraging the inherent structure of data, whether it's user behavior, environmental sensors, or financial trends, these algorithms can scale gracefully, even as complexity explodes. So what does this mean for the future? It means machines can make smarter, faster decisions in real-world scenarios, from personalized healthcare to autonomous vehicles. The math isn't just elegant, it's a blueprint for building systems that learn like humans, but without the coffee addiction. Next time you stream a show or check the weather, remember, behind the scenes, a battle between exploration and exploitation is happening, and kernelized contextual bandits are winning.